In section 10.3, we're going to talk about regression. So we're actually going to try to find, if there is correlation, find the line that would best go through those data points. Okay, so given a collection of paired sample data, so things that are paired, the regression equation, the line we want to find, we call y hat equals ax plus b. Okay, and this line would describe the relationship between x and y. So you can see that a is the slope of that line and b is the y-intercept. Okay, and we'll be able to find the linear regression equation in our calculator the same way we found the r value. So stat, then over to calc, and then you choose number 4, which is the linear regression. Now, we can only use the equation if there is linear correlation. So first we have to check and see if there is correlation using what we learned in 10.2. And if there is, then we can talk about the equation. But if there's not, that line isn't going to mean anything. If there's not linear correlation, we just let y hat equal the mean of the y values. So it would actually just be a horizontal line. So it would just be one number, the average. Okay, so our first problem says that we're looking at the Old Faithful geyser. So it says, can we predict when the next eruption will occur based on the height of the last eruption? So in other words, is there significant linear correlation between the height of an eruption and the number of minutes until the next eruption? Okay, so we've got 6 eruption heights and the times until the next eruption. Okay, so we're going to make a scatter plot. And along the x-axis, we're going to have the height in feet. So we'll go 50, 100, 150, and 200. Okay, and you're going to put those into L1 in your calculator. And then the time until the next eruption we'll put along the y-axis. So, and this is in minutes. Okay, and we're going to go 20, 40, 60, 80, 100. So I know you know how to make scatter plots, so I'm going to pause this and create the scatter plot. Okay, so here we have our scatter plot. And now remember, put the eruption heights in L1 and the time until the next eruption into L2. And then you'll do the stat over to calc and linear regression. We get our R value is negative 0.665. Now, just like we did in 10.2, we're going to use the table A6. And if we use alpha as 0.01, we get our critical value is 0.917. Now here we have a negative R value, and that's fine. We're going to look at the absolute value of R, which would be 0.665. And the absolute value of R is less than the critical value. So that means there is no linear correlation. Okay, so that means we can't use the AX plus B. We're just going to take the mean of the Y value, so the mean of the time until the next thing. So those are in your L2, so you would find the mean of L2. And when you find that mean, you get 76.83. So if you predicted anything, the best prediction we can give is that the eruption will be in about 76.83 minutes. Okay, our next problem says, can crickets really predict the temperature? So it says, some people claim that there's a linear relationship between the temperature and the number of times a cricket chirps in 1 minute. So the following data was collected from 8 random crickets. So we have their chirps per minute, which we'll put in L1, and the actual temperature we'll put in L2. Now I'll pause this and make our scatter plot. Okay, so here's our scatter plot. If you put those in L1 and L2 and you did the Statlin regression, we get the R value is 8.869. And if you use your chart with alpha is 0.05, we get the critical value is 0.707. So our R value is greater than the threshold value. So there is linear correlation. So now we use those values that the calculator gives us for A and B, and we can round to 2 or 3 decimal places. So we're going to have the AX plus B. So the A they give us is 0.054. We have X, and B is 25.87. And we can actually use this to predict different numbers. So it says if a cricket chirps 980 times in 1 minute, predict the temperature. So Y hat is going to be our predicted temperature, and we're going to put 980 in for X. So we'll have 0.054 times 980 plus 25.87. And if you work that out, we get that our predicted temperature is 78.79 degrees. Okay, and if we want to predict the number of chirps and the temperature if there were 800 chirps per minute, our Y hat, we take 0.054, plug in 800 plus 25.87, and we get there that the predicted temperature is 69.07. Okay, so we've got one more problem. It says, can we predict the population of the top 76 U.S. cities if we know the number of violent crimes in 1 year? Okay, so we've got data from 10 random cities, and the population are in the 1,000s, which means really the population is that times 1,000. Okay, you'd add 3 zeros to the end. So we'll put the number of violent crimes in L1 and the population in L2. Okay, if you make a graph of this, we've made a lot of scatter plots, so I'm just going to quickly sketch this. You can also do scatter plots on your calculator. But what we're going to get is we're going to get a whole, this isn't going to be exact, but it'll give you the idea. We're going to get a whole bunch of them kind of clustered here up low. And then if you look at New York City has a lot of crimes and a lot of people. They have an outlier that's all the way up here. So that's kind of what your graph looks like. A whole bunch down in the lower left-hand corner, and then New York is all the way up at the top. And you could obviously do this much more carefully. So when we put the violent crimes in L1 and the population in L2, the R value we get is 0.995. Okay, now using table A6, if we use 0.05, then our critical value is 0.632. So obviously R is bigger than the critical value. So we know there is correlation. And then from the calculator, we can get our regression equation, and we get that Y hat, we get our A is 0.183, and our B is negative 178.488. So now we'll use this to predict values. So it said Baltimore had 9,668 violent crimes, and we want to predict their population. So we would take 0.183 times the violent crimes, 9668, minus 178.488. Now here we get 1590.756. Now remember, these were in thousands, so if we want the actual population, we multiply this by 1,000, and we get the population approximately, is 1590756. So just over 1.5 million, or almost 1.6 million. Okay, and then it says Seattle had 3,865 violent crimes. So to predict their population, we would take 0.183 times 3865 minus 178.448. And that gives us 528.847. And again, we multiply this by 1,000 since The population was given in 1000s. And we estimate their population to be about 500,000. 528,847.